Hey, it's Dave here. In this video, I'm going to show you how to use RF with ESPHome in your Home Assistant setup, covering the wiring, the code, and how to capture signals from your existing remotes so you can recreate them as buttons in Home Assistant. This video is focused on cloning remotes, so taking an RF remote you already have and replicating it in Home Assistant. If you want to know how to use RF remotes or sensors to trigger Home Assistant automations, I'll be covering that in a follow-up video, so make sure you're subscribed so you don't miss it. The hardware I'm focusing on is an ESP32 development board paired with a CC1101 RF module. I did some tests with other RF modules like this one, but found the range was too limited to be practical. I've also been designing a carrier PCB in KiCad to make an all-in-one IR and RF hub, and have designed a 3D printed enclosure to house everything neatly together. The idea is to have a single compact device that handles both IR and RF, along with a few extra sensors like temperature and light level, all running through ESPHome. I've put quite a bit of thought into little details. For example, I've designed a small 3D printed soldering guide that holds over the IR LEDs and receiver, so when you solder them into the board, they sit exactly at the right height to line up perfectly with the enclosure every time. And rather than soldering everything directly to the board, I've used female headers for the ESP32 sensors and RF modules, so they are all removable and swappable. But I want to be upfront that it's still experimental. There are two variants of the RF modules with different pinouts, so I've designed the PCB to support both of them. However, I found the blue variant picks up interference noise when seated directly on the board, which I'm still investigating for a future revision. The green variant works perfectly, so that's what I'll be using throughout the video. Due to the two variants of the RF modules I've mentioned having different pinouts, I've put together wiring diagrams for both. You'll find links of those in the description, along with links of all the parts I'm using. And if you're interested in the carrier PCB I've been working on, I'll include a link in the description to that too. Just bear in mind it's still experimental at this stage. Now, this board was actually manufactured by PCBWay. Once I finished the design in KiCad, I just uploaded the Gerbil files directly using their KiCad plugin. You can see here it takes you straight to their website with everything pre-filled. From here you can define your PCB specification and adjust the shipping method to speed it up, or reduce costs by choosing a cheaper service. The boards arrived looking great, the silk screen is clean, and all the holes lined up perfectly. They also have a shared project section on their website where the community can share and download PCB designs, and I'll be uploading the carrier PCB once it's out of its experimental stage. I'll leave a link to PCBWay in the description. With that out the way, let's get started by programming the ESP32 board. From Home Assistant, if you go into ESPHome Builder and select New Device, select Continue, New Device Setup, and I'm just going to give this a name IRRF Hub Demo. Then I'm going to click Next. And the device I have is a ESP32, so I'm going to select the top option. And then I'm just going to click Skip. And you should see something like this here. Now I'm going to click Edit. Now the purpose of this is so I've got the API encryption key, over the air key, and a captive portal access point key. The Wi-Fi details are using a secret, so they're not going to change. So I'm going to copy this code and then overwrite it with the template I'm going to be using for this video. So as I overwrite it, it'll look something like this. Now I've tried to make this code a little bit cleaner and easier to understand by taking advantage of substitutions, which is basically like a variable. So you just set all the values at the top, and then the rest of the stuff as I scroll down is just referencing those substitutions. If you are using the exact same hardware that I've referenced, you only really need to change this particular part here. And if I just scroll down right way to the bottom, there's this part where you've got the button value. You'll need to add some buttons as you start getting the RF codes, so you can then create some controls or buttons to use. So if I go back to the top, device name is obviously your device name, and then you've got your friendly name here, API encryption key, over-the-air password, captive portal, access point, SSID is this one, and then your access point password. And if I just scroll down a little bit further, these are the GPIO pins that I'm using for my CC1101 RF module. I have specified the pinout in my GitHub channel, so you can just follow that. So you can see this is using 6 of the pins, and then the other remaining 2 pins is the ground and 3.3 volts. Moving on to the advanced RF settings, you can pretty much just leave these exactly as they are, but I've given you the option in case you want to do any of the fine tuning. And then you can see I've referenced here end of substitutions. So most of the settings below you shouldn't need to change. If you are using a slightly different ESP32 board, you might need to change this where it's got framework type to something else. But I'm just using a standard ESP32, and that is the appropriate settings. If I just scroll down, you can see all of these values are basically just calling substitutions. So you don't want to change any of these because they're set from the above. And again, if I scroll down, you've got the buttons section. You will need to add some values later on. I'm just going to quickly split this screen into half and show you which values to change now. So this was the code we made earlier when setting up the new board. So I'm just going to copy the name and friendly name, then the API encryption key, then the over-the-air password. Next is the access point SSID, and then the access point password. And it should look something like this. Now, just before I flash this board, I'm just going to move over to the other example code for those of you who want to use a combination of the IR and RF transmitter, along with some sensors like light sensors and temperature sensors. So for those of you who just want to use the RF module and ESP32, press skip and we'll move on to the flashing the board section. So this is my example code if you are using a combination of IR and RF transmitter along with light and temperature sensors. From the top, I've taken advantage of substitutions again, and you will need to update these values on the board you've already flashed. If I just scroll down a little bit further, again, you've got the GPIO pins used for the RF module, which is 6 of them, and then the other 2 are ground and 3.3. Where you'll see additional settings is here is the pins used for the light and the temperature sensors. So they are actually sharing the same GPIO pins, but we get around this because in the code below, it references different addresses. This is the light sensor, and this is the temperature sensor, and there's 2 variants which I will go in more detail as we scroll down in the code. Again, you've got the advanced settings for the RF transmitter receiver. I'm just going to leave those exactly as they are. And as I scroll down a bit further, you'll notice this extra setting for the infrared settings. Again, I'm just going to leave those exactly as they are because I found they were the sweet spot for the devices which I'm using. And in this example video, I'm using a combination of IR transmitter LEDs, a VS1838B IR receiver, along with a transistor and some resistors. This part you may need to change if you're using a slightly different ESP32 board. And as I keep on going down, you'll see this I2C setting is for the light and temperature sensors, which are sharing the same GPIO pin. Here you've got remote receiver, but this time you'll see I've referenced the RF receiver and I've also referenced the IR receiver. Now, one of the mistakes earlier on is when you are using multiple remote receivers, you're going to additionally need to specify an ID here and here, because if you haven't got that referenced, it's going to see a form of duplication. You probably won't see any errors as you're writing the code, but as soon as you start to flash it, it's going to throw an error message, and it's something that caught me out. So I've purposely included this in this code, and I've also included it even if you are only using one or the other. So if you later adopted to using a combination of the two, you won't run into that problem. Same rule applies also for the remote transmission part. You must include ID here and ID here as well, so that there isn't a form of duplication. Again, you'll need to start adding your buttons later on once you start receiving the codes and programming controls. This is the code for your light sensor, and although the light sensor and the temperature sensors do share the same GPIO pins, you'll notice here I've got address field which is slightly different to this address which is used for the temperature sensors. So that way they're both sharing the same pinouts, but they're using a different address. I've set the light so the update intervals is every 60 seconds. If you wanted to make that sooner, you're welcome to change it. Now with the temperature sensors, which is this last part of the code here, you've either got the choice of using the BME280, which is slightly more expensive. It's almost about 3 times the price of the other one, but it does allow you to have temperature, pressure, and humidity, where the other one below, which is the BMP280, only provides temperature and atmospheric pressure. And just be really careful with your wording when you search for these, because when I was searching on various websites, some of them actually include the same part code, or you might think you found a really cheap BME 280 and it's actually a BMP 280 that doesn't include humidity. So just be careful when you're searching for those devices. At the moment, I've set the code so it's going to default and use the slightly more expensive one, which is the BMP 280. And if you did want to use the one below, what you'll need to do is comment out this so it looks something like that. And if you just delete these comments, now the other temperature sensor is going to work and you'll be able to flash the board. I'm just going to quickly undo that because I'm using the other one. And just before we flash that, I forgot I haven't changed the values here, which you'll need to set. So I'm just going to quickly split the screen into half like I did earlier. So on the right, you've got the code that was created when we set up the device in ESPHome. And I just need to overwrite some of those values onto the left, such as the device name, friendly name, API key, and so and so. So I'm just going to update the name and friendly name, API encryption key, over-the-air password, and then the access point, SSID, and password, which is these two here. Now I'm going to click Save, click Install, and because I haven't already flashed it, I can't choose wirelessly over the air, so I'm going to choose a second option, which is plug into this computer. Now this part may take a considerable amount of time, around sort of 3 to 5 minutes or longer, because it's got to compile the code to generate the bin file. Now might be a good time to grab a cup of coffee. Once that's finished compiling, you're going to select Download Project. You may get a warning like this and just select Keep. And now I'm going to open ESPHome Web, select Connect, and now I'm just going to plug in the USB port to my ESP32 board. And I can now see COM port 4 is showing. So I'm going to select that and choose Connect. I'm not going to choose Prepare for First Time Use because we've already generated the bin file. So we're going to choose Install, browse to the path where the bin file was downloaded. And in my example, it's my downloads folder. then click open, and just before I click install, I'm going to hold down the boot button. That's looking good, it shows erasing. Now that's finished flashing, I can click close, close that tab down, and then just close these other windows. And now I'm going to go into Settings, Devices and Services to find that new device. So Settings, Devices and Services, and you can now see it here, so I'm going to click Add and then Submit. I'll leave the name as it is, and for the area, I'm going to set it to Lounge and then click Finish. And you can see here I've got the light temperature, the humidity, pressure sensor, and the temperature. And there's the option to restart the device if I want to. Now, if you were using the other example code where it's just using a combination of the ESP32 and the RF transmitter module, then these sensors above will be missing and you'll only have the restart button. Now that we've flashed the ESP32, we're going to head over to the logs and start capturing buttons from our remote to clone the codes. From Home Assistant, if you go into ESPHome Builder, and I'm just going to find that device, which is this one here, and if I click in the logs, now I've got a set of curtains which are RF controlled, and I'm going to press the Open Curtain button. And you can see here it's referencing this Pronto data code. Just before I press any more buttons to receive additional code, I'm also going to filter the dump so it only shows Pronto data. So if I go into Edit, and I'm going to look for Remote Receiver, which is this one here for RF, and the value dump I'm going to change from All to Pronto. And just warning you, this is case sensitive, so if you added a capital P, it's not going to work. From my GitHub repo, I've saved some of the options that you can use to dump for, where it's listing different variations of codes. You can either edit it from this particular part, or you can make it as a list. So if I just go back into ESPHome, if I comment that out, and I'll just quickly make a new line, and then do 2 spaces, hyphen, space, and if I type in RC underscore switch, you could have that, and raw, and what that would do is show those 2 codes only. But for my scenario, I'm just going to delete that and then uncomment it because I want this Pronto data only. So I'm going to leave it as that, and I'm just going to click Save, click Install, and just wait for it to flash again. Now that it's finished flashing, I'm going to press the Curtain Open button again. And I'm going to copy that section in green of the code. Now, just warning you, it doesn't always work perfectly each time. So when you're creating these buttons, you might want to copy that chunk of the code, make the button, flash it, test it, and then move on to the next one. But I'm just going to assume that works and copy that code temporarily into Notepad. And now you can either press the Curtain Close button, copy that code, and also temporarily save it somewhere, and then start making your buttons all at the same time. And then once you've got that code, if you go to my GitHub repo, I've included some example code for the Pronto data that gives you a template to create this button. The only thing you'll need to change is giving it a name and then pasting in your data here. Now, while I'm covering Pronto data to create buttons when listening to those codes, on my GitHub repo, I've also listed some other examples based on the codes and how you create the buttons. So hopefully this should be enough for you to understand. Now, AI can be quite useful at formatting this template for you, because what I'm going to do is copy this, and now I'm just using Claude as an example, and I'm going to ask it to make a button using that template along with the Pronto data. And another cool feature is if you press these three dots, which is the backtick button, followed by YAML, and then you press enter, it goes into a sort of coding section where you can paste in that template and it's still got its formatting. And now I'm going to type in the Pronto data below. And I'm just going to paste in those entries, click submit, and it should give me a nice template button. Sometimes when it does this, it doesn't always make that data in one line. In this occasion, it's done it perfectly, but if it has done it where it's just one long line, you can always just say, can you tidy it up and make the data in multiple lines? So this is looking good. I'm going to copy that. Now I'm going to go back into ESPHome, scroll down to the buttons section, and I'm just going to paste in that template. One thing to watch out for with AI is it doesn't always get the indentation start point correct, because you'll see this template should be 2 indentations to the right, like this one is. I'm just going to fix that. The rest actually looks good, but this should be aligned with the platform part. So I'm just going to move that so it looks like this. And I'm going to give this button a name, and I'm going to call it Curtain Open. Now you can either flash the board, test that button works, and then start making a load of buttons, or you can just add them all, flash it, and then triage which ones don't work. Because I do find that this data doesn't always work consistently the first time you create that button, so it may take a couple of attempts and then it's working. I'm just going to quickly repeat the same for the curtains close. And just before I flash this, I'm going to go back to that dump section, and I'm going to change that back from Pronto to all. The reason I'm doing that is when you're later creating other buttons, and let's just say that they weren't in that Pronto code, you'll probably be wondering why it can't see the signal, and it's because you just need to change that filter back off again. Now I'm going to click save, click install, and then flash wirelessly. Now it's flashed, I can close that window, close that as well, and if I go into settings, devices and services, do a search for ESPHome, and I'm just going to find that device, which is this one here, and now you can see you've got these two buttons, you've got curtain close and curtain open. So I'm now going to transition to a recording where I can just demo this is working. So this is my dining room area, and I'm going to press the button shortly, but I just warn you, the curtain in the middle is the one we're controlling. The other two are separate systems, but they are synced, so they have a delay when that curtain is opened and closed. I did have to go back on myself and change one of those buttons because the code didn't work as I warned you. So now I press the curtain open button, you should see the curtain opens. The two on the left and the right will open eventually, but that's a separate system that isn't related to this. And now I'm going to press the curtain close button, and you should see immediately the middle one's going to close, and then the other two in sync will close after, because the other two are 2-year based curtains, where the middle one is 2-year based, but it's also got the option of RF controlled. Now that you know how to create buttons, let me show you what Home Assistant can do that your physical remote simply can't. I'm going to create an automation that automatically closes the curtains when I leave the flat, triggered by the Home Assistant companion app on my phone, detecting I'm no longer home. Let's get back into Home Assistant and set this up. From Home Assistant, if you go into Settings, Automations and Scenes, and select Create Automation, Create New Automation, and if you click on these 3 dots and select Edit in YAML, and I'm just going to paste in this example code. So this section is the trigger state, and when the entity of a person has changed from home for longer than 2 minutes, it's then going to perform this section, which is the action, where it will be a button press to close your curtains. So you'll need to update both this value and this value. So I'm just going to open up another tab to show you where to get those from. So from the Home Assistant main page, go to Settings and scroll down and look for Developer Tools and make sure you're on the States tab. And if you just do a search here for person dot, and you can see in this example, I've got two people to choose, and the one I want is person.dave. So by clicking on that, I've now got the entity ID, which is person.dave. So I can copy that. If I go back into the automation tab, so I'm now going to overwrite this value. And now I'm going to repeat the same for the curtain button. So if I go back into the Home Assistant main page, go to Settings, Devices and Services, and do a search for ESPHome. And then just find that IR/RF hub. And you can see here I've got the curtain close button. So if I click on that, go to Settings, and here I've got the entity ID. So I'm going to copy that as well. Go back to the automations page, and I'm just going to overwrite this part. So now it's got button along with the entity ID. Now I can click Save, click Rename, and that automation is ready to go. If I just click on these three dots here, and I'm just going to go to Edit in Visual Editor, you can see this is the trigger state. When person Dave state changes from home greater than 2 minutes, it's then going to press this button, which is my lounge hub curtain close button. So there you have it. You've got your RF module wired up with ESPHome, captured signals from your existing remotes, and should now be able to clone them as buttons and create automations limited only by your imagination. Let me know in the comments section what RF devices you're planning to control, as I'd love to hear what you've come up with. And as mentioned, a follow-up video is coming where we flip it around and use RF and IR sensors as buttons to trigger Home Assistant automations. So make sure you're subscribed so you don't miss that. Thanks for watching, and I'll see you in the next one. Bye for now.